Thank you. So this talk, well, first of all, thank you for coming. This talk is about an application for doing database editing. And the agenda is quite classical. I'm first explaining why we did that, give you an overview, then how you get started to use it, and finally how it works internally. So the introduction is one need that we had. I'm Laurent Dami. I'm working at Geneva Courts of Law, Justice Department. And we had this need that we have our regular application for our internal users accessing the database. We also have the database administrators who manage the database and access the same database. But we also have a support team. And that support team sometimes has to deal with the data, actually manipulate the data in some ways that are not allowed in the original app. Because the original app, of course, does a lot of checking. And in particular, since it's a justice application, people cannot go back. There is no undo. But sometimes they do make mistakes, and we have to correct the data. So the way we do it is through this support team. The question was, what tool should we give to those people? And before we had an old database with some tools which were quite appropriate for doing that. Then we moved to Oracle, and we're kind of stuck. What is there to edit the data within an Oracle database? The kind of needs we had, well, was of course to have access to the complete database schema, to be able to do CRUD. CRUD is, you know that acronym, create, retrieve, update, delete on all data. And to navigate in the data, this is the most difficult part, to navigate in the data following the relationships. So if I have one record, and that record has a foreign key to some other record, I want to be able to jump to the other one, not to type the criteria each time I want to access another record. And another need for our support team was to prioritize the way you access data, because some of the tables you never ever work with them. They are very stable. And some other table, you deal with them all the time. So of course, if you have a tool which is just a stupid alphabetical order of your tables, then you're going to spend a lot of time searching just to enter the table that you want to access. So it needs a little bit of customization, not just a plain tool for the DB admin. So what could we do with such needs? We could program the whole thing, program an admin GUI in our application, but that's a lot of work. We could give them a DBA tool, and that's what we did for a couple of months, but it was not very convenient. So in the end, the solution was to give them a CRUD app. Now, what is the CRUD landscape, or what was it at that time? You have a bunch of tools that you can just use straight out of the box. And I guess every database vendor has something like that. So in Postgres, you have a Postgres admin. In MySQL, you have a MySQL admin. You also have something like that for Oracle. And you have also some tools that do that kind of thing in a generic way. So the plain old PHP myadmin can talk to several kinds of databases. You can just use it directly, but you cannot customize it. On the other hand, you have the family of scaffolding tools that we have known for many years. But there you have to program before you can start working. So what we're interested in is that corner of things that you can use them straight off the box, but you can customize them to be more specific to your needs. And actually, I just discovered very recently, this year, 2014, seems to be very rich for such kind of applications. Because we have a Rapid app, which came out in February. I just discovered yesterday that there is this interchange table editor. I didn't know it before. Tim Boons has released something called Web API DBIc, which also does more or less something similar, but in a more service-oriented way. So that thing here is really meant to be used by programs, not really by humans. It can be used by humans, but not for very regular work. And so this is just to explain that at the time I started working on this one, well, there was not so much of a choice. So this was the motivation to write one. And now you are going to see that it's good that we have several choices because they have different IDs. So some of the IDs that I'm going to show here, I didn't find in. Of course, I'm also missing a couple of features that I find in other products, but okay, there is more than one way to do it. Okay, the main features we have here, we have very powerful search syntax. We have this notion that every resource has a URL. Every resource, it means not only every table and record, but also every search form, for example. Every pre-filled search form with some criteria has a URL, so users can bookmark them or link from other applications to this one. We can navigate through hyperlinks from one record to the next. We can do, we can do some bulk operations and customize a bunch of things. So now we are going to see that on the screens. So this is the home page. By the way, all of this is, there was very little effort in to make it like a nice looking application. So don't be surprised, these are plain screens with very little fancy widgets, but the functionality is there. So this is the home page of the application. We can have multiple data sources. So there is a config file somewhere where you say which data you want to connect to. Here I took two free sample databases that you can find on the internet, and both of them are quite convenient to play with data because it's rich. It's not just two tables, it's about 20 tables, so you have something which looks real. And also there is a couple of thousands of records on those. And also those two databases called Chinook and Sakila, they have various versions for various database vendors. So what I'm using here is SQLite database because it's very convenient for testing and demo, but they also have the same database in MySQL, Postgres, and so on. So we have seen the home page with several data sources. Now when you get to one data source, this is what you see. You see, of course, the list of available tables. And first thing to notice is that the tables are grouped. So this is not just a plain alphabetical order of tables. There is some user logic into that. Of course, it doesn't come from free. It comes from a configuration file where I specified all of that. And we are going to see later how the specification looks like. So we have table groups. So this group contains all data which talks about music. This group contains all tables that deal with selling the music. So it's more practical for people having to deal with that data. And all of this is, there is a little bit of dynamic HTML in it. So all of this is displayed in a tree navigator that you can close and open, collapse or expand the parts that you want. You can do that either with a mouse or also with a keyboard to open and close. And from each table, then you can navigate to either a search form that we are going to see next or a description form. So this I said, this, oh, and by the way, all of this works with an ORM called DBIx DataModel. So it's not DBIx class. There is more than one way to do it. And either you have DBIx DataModel schema already written, or it can generate one on the fly. And this link here is just to show the Perl source code that was generated when it's generated on the fly. Okay, so now we go to the table description screen, and it's the same idea. We show all the columns in one table, but we show them in some structured way. So we have column groups, and the groups are ordered, and the columns within one group are also ordered. So this is a decision you make when you put together the configuration file, and you make those decisions according to which table you work with. You put them in the front. For each column, we have some information here, which is actually a mix. Part of the information comes from the database schema. So we go to the database to ask what is the data type of this column, what is the size, maybe some constraints like not null. So all of this is already in the database. And on top of that, we also can have some information which is in the config file, like, for example, a comment, descriptions of those columns to make things more user-friendly. So it combines the two sources and puts that into one screen. Another thing we have here is we have hyperlinks. Oh, sorry, I pressed the wrong buttons. We have hyperlinks to related tables. So this information we get from the database schema, that there is this foreign key is a reference to some other table, and from that we generate the hyperlinks. Summarizing, grouping, ordering, and hyperlinks. Now we come to the search form. The search form has the same groups of columns that we saw just before. So we can, they are grouped and they are ordered in the same way. If you have lots of columns, you can still collapse or expand some subsections of that form. And okay, within the input fields here, we use what I was presented yesterday, which is the module SQL Abstract From Query. And that module does some parsing on what users type here. It means that when you specify a search, you can either just give a single scalar value, or you can, as in this example here, you can give a list of values, and this will become OR in the database request. Or you can have a value with a star, and then the system will guess, okay, there is a star, so probably the user here wants a like operator, and the parser will detect that automatically. Or you can have this construct, which is called between, and this will generate the appropriate request to the database. So you have a lot of power using this parsing methodology. And as I was mentioning yesterday in the other talk, the syntax can be extended. So if you need, either you need to specialize this syntax for your specific database product, or you want, instead of between, you want to say that in French or in German, or other things like that, then you customize the parser and you plug it in this application, and you get an extended behavior. Other things to say about this screen. So the first section is about the selection criteria. The second section is about parameters to the query. In those parameters, you can say some paging options. You want 50 records at a time, 20 records at a time. You want the page 1, 2, 3, 4. What kind of view you want as a result, and we are going to see the different views after that. And you can also choose on the right-hand side, you can choose which columns you want to display in the results. Maybe you are not interested in all columns, you just want to do a search on some specific subset. And this is organized in groups, so if you click in a group checkbox, of course, it will automatically check those. If you don't click anything, by default, you get all the columns. And here is what you get as a result. The result is displayed again in this tree navigator. So it's not a grid. Many other tools like this, they will display the results as a grid. Where you have rows and columns in a square manner. Here we have a record-wise presentation. You can still open and close the records to investigate them. It will only display here the non-null fields to make it more compact. And you have hyperlinks. When one column is a foreign key to something else, you have hyperlinks to navigate to all of this. It works both for one-to-many or many-to-one relationships. So if this is, so for example, album ID, this is a foreign key to the album table. So if I click on this one, I will get a single record from the album table. Whereas here, the track ID is our primary key. You see that because it's underlined. And I can have many playlist tracks that reference to this track ID. So if I click on this one, I will get a list, of course. And all of this navigation is just straight HTML navigation. So there is no fancy tabbing or other stuff in the application. It's the user. If the user wants this this link to be displayed in a new tab or a new window, they just use their regular browser methods. Open in new tab, open in new window. So what is programmed here is just a plain usual href. I think that's all I wanted to say on this one. No. So here we see one page of 50 records. Of course, there are hyperlinks to go to the next page or to the previous page, but we have a little bit of JavaScript dynamic HTML here. It understands the key that you press. So if you press the left or right arrow key, it will automatically click on those links to go to the next page or to the previous one. So you can navigate quite quickly with that. This is another view of the same search. Here we use the wonderful module which is called Excel Writer. So the output, instead of being HTML, is an Excel file. And this is why we didn't bother to write a grid view in HTML, because if people want to think of that as a grid, well, let's use Excel. Excel is excellent for doing that. You may notice that the Excel is not just straight values in Excel. We use a little bit of the interesting features of Excel here, which is there are column groups. See, you can click on those to collapse or expand the groups. That's a native feature of Excel that you can program when you generate such a file. And also, we automatically put the auto filter things so that people can select the content. I wrote this for Excel because my shop is a Windows shop. I know it's not so frequent in the Perl community. I haven't looked yet in how to produce the same thing for an OpenOffice or LibreOffice output. I'm pretty sure it could be quite easily to add, but it's not done at the moment. But hopefully it will come later. Another view is still with the same search. I can output that as YAML, and actually we use that quite a lot when we have a problem and we try to investigate the problem. We extract the data as YAML, give that to the developer, and the developer can try to understand what is wrong with it. So it's a convenient thing to have. And that's it for the views. Of course, you can program some more views to have more formats for output. Now we're going to talk about the updates. So the updates, well, you can do bulk updates in this application, which also I think is not so common in those kind of CRUD applications. So the first way we're going to see is a bulk update on checked records, which is written here. So the idea is that in this page which is displayed, each record has a checkbox. And so you decide which ones you want to modify, maybe only one, maybe several. Then you click on the update link, and you get to the update form. And the update form is pre-filled with the key of the records that you want to modify, and here you just specify the new values that you want to put. So of course, this is going to generate the SQL update this and this fields from the left, where the track ID is equal to one of the numbers on the right. So this is the first mode to do some bulk update. The other one is to do a bulk update on the whole result set. So this time we're going to select this option. We no longer check the records here, but we will just take again the criteria from the search. So the search that was here with some conditions, this is going to be the source for my bulk update. So I guess if you have done this in SQL, it's pretty obvious for you how this works. But usually this kind of update is done by programmers. Here we enable some users to do the same. So then they get to this screen here, where on the right-hand side you have all the criteria, and on the left-hand side here you have what the new value is. So here I'm going to update the unit price of a number of tracks. Of course, this is very powerful and might be very dangerous to your data. So you won't give this power to everybody. But remember, this was built for as an admin tool, more or less. We give it to our support team, which know how to deal with the data, and they take their risks, but they also take the power. But don't give that to your end users, or they will destroy your whole database. Okay, now the URLs of this application, I put the plus or minus sign here because it takes the RESTful idea, as you can see from the names of all the URLs here. So search, list, ID, and so on and so forth. But it's not a fully REST API because all of this is meant to be used from the browser. It's not meant to be used by an end program. So we don't really have, at the moment, we don't really have the other verbs from the HTTP protocol. We don't have the put and the delete. So I very well know that you could simulate that, do some tunneling, and have both the best of both worlds. Probably this will be done in the future, but at the moment it's not implemented. So all we have is get and post. And of course, when you get, any get will never modify the data. So when you get on a URL which is called delete, actually you don't delete anything. What you get is you get the form to delete the data. And then only when you post to the same URL, then the actual delete takes place. Okay, we spent already quite a lot of time. Now I say getting started to use it, to implement it in your environment. As I said, you need a config file. So here is the minimal config file that you need is just to say how to connect to the database. Pretty obvious. So you give all the information to do the DBI connect method call, and that's it. All the rest is optional, but this you need. And now the rest is specifying those groups that I was talking about before. So here is an example where I create the group of music tables, and I say which tables are in it, in which order they are, and maybe with some comments and descriptions. And all of this helps to produce more user-friendly screens. Same thing with columns. So here within one table we specify the column groups, same idea, groups, ordering, and descriptions. And to get started, the only missing piece is you need a PSGI file that really starts the application and gives you back a Plack application. And then you can start it. I don't know if you were at the Plack presentation just before by Sauer. There's various ways to start the application. Either you start it from the command line using PlackUp, or you insert that into your Apache using the handler for that. Or, well, there are many various servers that can support this and get you started. That's it for how to get started. Now we are going to talk a little bit about the architecture. So this is a global view of the external components that are used to implement that. I'm going to go in more detail in all the sections, but you see it's the traditional model view controller separation plus some infrastructure modules. So we'll start with the infrastructure. This uses Moose for object-oriented stuff. It uses YAML for the config data. Well, actually, this can be changed if somebody wants another configuration data. All that the application wants, it wants a Perl data structure. It doesn't care if it's YAML or JSON or config or whatever. I prefer YAML because I think it's a very good compromise between something which is machine readable and something which is human readable. But again, it can be changed very easily. If you remember from the PSGI slide, it's in the PSGI that we connect the config with the object. So here you have the freedom to choose something else. And data domain is a module for data validation. Right now it's used only to check that the config is correct. I haven't checked. I don't do data validation for user input at the moment, so it's only the database that does that. But of course, it could be also extended in that direction. Now, for the controller family of modules, we have Plack. We have CGI expand. So CGI, it has nothing to do with the plain old CGI. So we don't use the old CGI.pm. But there is a very nice module called CGI expand, which does a very simple thing. It takes the when you have a HTML form, all you can have is it's a flat model. In the HTML form, you have names and you have values, and that's all there is to it. Or at least that's all that the server can receive as data. And the idea here is that in the name of the field, you can have some structure. You put some dots, like here, foo.1.bar. This is regular HTML. And the CGI expand module will translate that into a nested Perl data structure. And then the application can use that as input. So it's very convenient. And SQL abstract from query, again, it's the parser that takes what comes from the search forms and translates that into SQL. About the model family, so of course we use DBI. That's what everybody uses to talk to a database in Perl. We use DBIx DataModel, which is the ORM that I wrote. Actually, at the same, it went out in 2005, so just at the same time as DBIx class, and from then on it has continued its own life. I won't talk today about the difference between those two ORMs. Just remember there is more than one way to do it, and if you want more information on that, there are some slides on SlideShare where I discussed that 2 years ago. And finally, the SQL Abstract More is the module that does the SQL generation. The view modules, we use Template Toolkit. We use the Alien GVA script, which it's not Perl, it's just JavaScript to implement this tree navigation. So that's something we have in all our applications in Geneva, and I just reused it here. And I know Prototype.js is a bit old. It's not the latest high-tech technology in JavaScript, but so far it still works well for me, and I didn't have time to think of moving to something more modern. And we have seen this Excel generation module. Now, some words about the internal structure of this application. The entry point is the AutoCRUD class, which is both a Plack component and a Moose object. It inherits from both. And then it talks to a number of module, again using this classical model view controller structure. So beware, here there is an arrow. So this is inheritance. This is inheritance, but this is not inheritance. It just says that this guy here talks to that guy, talks to that guy, talks to that guy. So we are going to see each box in a row. The entry point, its job is to assemble all the subcomponents. So it will look what modules, auto-discover the modules. As I said, it's a Plack component, and all the information it has a name, it has a configuration, and it has a list of data sources. That's it. Data source, well, that's the way where we talk to DBIx DataModel schema. So it will get from there the foreign keys, table, list of columns, and so on. By the way, all of this right now only works with DBIx DataModel, but one extension could be to do another version of that one to talk to DBIx class. I think it could be quite easy, and then it would work for both worlds. So this is another item on the to-do list. The context is very similar to the Catalyst context, if you worked in Catalyst, but on a much smaller scale. So for each request, we instantiate a context object. That context talks to the request. It talks to the data source. And then at some point, it knows which view to apply, and it just puts all of this information together for the lifetime of one single request. And then it's thrown away. The schema, again, is the controller that talks to the database schema. And the table module, this is where most of the work happens. This is where we implement the CRUD operations. And the view, well, we have this collection of views. Each view is a subclass which has just one method called rendered to produce the output. And of course, this is extensible. So talking about extensibility, all of this is Moose, so you can use the Moose mechanisms of subclassing or roles, whatever, to extend. And this is what we did actually for our Geneva needs. There is this application that I'm talking about, which is the published version, app AutoCRUD, which has the generic behavior. And we have a subclass of that with some internal code which is specific to our environment and which is not interesting for the rest of the world. So we have those two layers. For example, what you can do in the subclass is you can customize the query parser, or you can do something specific related to the user that is issuing the request. You might want to check if that user can really do this operation. This is something that typically you would put in a subclass. If you add some new controllers, these automatically become some new URLs. If you add some methods in one controller, again, it becomes automatically a new URL. So this is how it is done now. I would say it's more or less because of laziness from my part. I know it's not a very nice decoupling of things, so probably this at some point should be re-implemented with a path router or something like that. I didn't want to put a whole Catalyst framework into that. That would be too heavy because the URLs are quite simple. So this is why it's hard-coded in it, but probably it can evolve in the future. Also one thing here is that most URL are decided dynamically depending on which database we connect to. So the static part in the URL, it's just schema, table, delete, update. So we have, I don't know, maybe 10 reserved keywords. So this is not really worth for having a complete web framework doing that. Adding views, well, if you add a new view called XYZ in the hierarchy of modules, then automatically any URL which ends with XYZ will go to this view. So this is where we implemented that. You take one URL .yaml, it goes to the YAML view. One URL .xlsx, it goes to the Excel view, and so on. So if you want to relook that, you can override the CSS. You can override some of the templates. Again, the templates are in a kind of object-oriented inheritance. So you can decide to override just one template and keep the other default templates from the parent application. And that's more or less all I wanted to say. So in conclusion, we have an application for our internal needs. It does most of what we wanted, but there is still room to improve a lot of things. And I hope it could be interesting to other people. I also hope that it could be interesting to people outside of the Perl community, because there is nothing specific to Perl in what we have seen here. So if you have been to all of these talks about Perl is dying, Perl has problems, what we need some applications to show to the world that we are great. I think this kind of stuff, of course it needs a bit marketing, it needs a bit more nice looking screens and so on. But I'm pretty sure that this is an area where many IT people outside of the Perl community would have needs for that kind of thing. And any help is welcome. And yes, that's it. I just before I go to questions, I would say that it's very new that there are so many other CRUD applications. That's what I said at the beginning. So obviously now the next thought is, should they all evolve separately, or should we try to find a kind of common layer to share some ideas, or even share some code between those things? So rapid app, table editor, and so on. I haven't thought very deeply about that. I haven't talked to anybody about that, but that's definitely a direction I'm interested in it. So if there are, for example, I don't know if there are some people from the table editor team here. Doesn't seem to be the case. Well, I'm open to discussions. Now, if there are any questions, you're welcome.
Any questions?
You showed this very nice interface to categorize tables, for example. And
yeah.
Is this possible only via config file, or is there via web interfaces also possible?
Right now, it's only in the config. But of course, somebody could come up, write a web interface to edit the config. But right now, no, it's only the config file.
Any other questions?
Do you have any plans regarding the documentation of deployment on the MetaCPAN? I was just looking at the depots, but there are some still only the description of the modules. I mean, to make the spreading more easy.
You mean to give that as a package that people can install,
yeah,
without having
or,
CPAN?
or maybe at least write a few words about how to deploy, how to configure the system so that it runs automatically, etc., etc.
Yeah.
Sort of for the newbies.
Yeah, I agree that this is definitely needed. Well, first of all, it should have a website on its own to advertise the whole thing and show some videos, and I agree. It should be possible to install it, just having a Perl on some system and having that. But this requires some more work, and I only have 24 hours, so it's not done at the moment.
Any other question?
What happens if you enter the wrong type of data in a field? For example, in our integer field, you enter string.
Okay, as I said, right now there is no data validation within the application. So this goes just directly to the database, and then the database will complain, and the database will throw the exception, and then we display the exception in some way.
Okay.
Yes. Mm.
Any other questions? Okay, let's thank our speaker.
Thank you.
Now a quick coffee break, and then we're moving on to the keynote in Vitusha.